Only a few months ago, we got Swift 6, the biggest update to the language in many years. And now version 6.1 is out. So I guess the question is, can today's update offer anything interesting? Let's find out. Hey there, I'm Yakov, and in this video, I'll go over the key changes shipping in Swift 6.1. It's a minor update, but that doesn't mean it's not worth our attention. So let's have a look at what's new in Swift 6.1. Task groups in Swift let you run multiple blocks of code concurrently, but wait until all of them finish before proceeding. This should sound familiar to anyone who's worked with dispatch groups. But unlike them, task groups structure the work using child tasks. Each task can return some value, and the group itself can do the same. Previously, you had to specify the return type of child tasks explicitly. But in Swift 6.1, the group tries to infer the type. It does so by looking at the first child task within the group. This updated syntax makes your code just a little shorter, but you don't have to use the shorter version. And you know what? Sometimes you might want to stick with the old syntax with explicit type declarations. Here's an example. Suppose you're managing a farm which makes two types of products, crops and milk. When you want to calculate the farm's revenue, you obviously can't add different products together. But the product protocol lets you use their monetary values instead. Before the change, you had to explicitly specify the return type of child tasks. In Swift 6.1, you don't have to do that. But now you've got a new problem. The return types don't match, and the compiler refuses to build such code. One solution would be to leave a hint of the return type in the first child task. Then the group would expect the same type from other tasks. But I don't really like this approach. That's because it limits your ability to change or reorder child tasks. Remember, the group only infers the type from the first task, so the order does matter. In this case, I would just continue using the old syntax. Another solution would be to return dollar amounts from the very beginning. This would automatically make all child tasks have the same return type. But this would also limit the available actions. What if product defines other properties which you need to calculate revenue? You could use tuples, of course, but this would only make your code even more complicated. That is to say, not every syntax update makes the code better. In simple scenarios where all child tasks have the same type, this change is a welcome improvement. But in more complex cases, you might want to stick with the old way. Another change in Swift 6.1 is the updated compiler behavior when it resolves member declarations. In simple terms, when you call a member functions defined in another module, you have to import that module explicitly. This helps you avoid situations where you accidentally called the wrong version of the method. For instance, let's say your project depends on a Swift package with two modules, and within that package, one module depends on the other one. Then, let's say module B declares a method in an extension of the built-in string type. Now, if you import any of the two modules anywhere in your app, this extension method will become visible for the whole app, even if you call it in a file without any imports. And here's where everything falls apart. Imagine now that module A declares a method with the same signature. How can you control which implementation is called in your app? Can you even know that for sure? Of course, the implementation is not selected completely at random. But the rules are so complicated, you're nearly guaranteed to make a mistake. Moreover, if you or someone else changes that other import in the app, the method's behavior might change unexpectedly. Basically, that's why I think extending types you don't control is a bad idea. And while Swift 6.1 doesn't prevent signature collisions in the first place, at least it makes it easier to control which implementation you want to call. When you enable member import visibility, the compiler will narrow down the scope of imported members visible in the source file. At this point, if you want to use that string extension, you have to import the specific module where it's defined and do so in the specific source file when you want to call it. For instance, if the method you need exists only in module B, then you have to import module B directly. Even though module A depends on module B, importing module A won't make the method visible. On the other hand, if module A introduces a method with the same name later, your app will continue using the right implementation without any extra effort from your side. A Swift update which makes code more predictable and reduces maintenance costs is definitely a step forward. Just keep in mind that for now you have to manually opt into the new behavior by enabling this upcoming feature. I've been using the new versions of Swift, Xcode, and iOS SDK from the very first beta. And I gotta say, it's been one of the smoothest upgrades I can remember. The couple of iOS and macOS projects I work on had zero build errors and even no new warnings. So I'd say switching to the new version of Xcode shouldn't give you much trouble. However, the upgrade process itself may be less convenient than you're used to, especially if you need to install the new version on more than one computer. That's because Apple no longer publishes simulator runtime images on the developer portal. Instead, you have to download them from Xcode settings. But when you need to install the image on multiple computers, you obviously don't want to download it many times. In that case, you can use a terminal command which will download the runtime, install it on the current computer, and export the image to a folder you select. Then, on each of the other computers, you import the image without downloading it again. This sort of solves the problem, but I wouldn't call this new way as convenient as the old one. In summary, I wouldn't call any of the changes in Swift 6.1 bad, but some of them are kinda controversial. The updated behavior of module imports is definitely a welcome improvement. It prevents you from accidentally calling methods you didn't even know about. Basically, it becomes much harder to mistake one method for another. The simplified TaskGroup syntax looks just a little bit cleaner, though it can also be more confusing as you've seen in my illustration. But I can't really understand the removal of simulator images from the developer portal. To me, it looks just strange. Downloading runtimes becomes less convenient, and I don't really see what Apple wins by undermining developer experience. Nevertheless, Swift 6.1 didn't cause me any trouble in any of the projects I used it in, and that automatically makes this update an okay one. Maybe the next version of Swift will be more exciting. Here's a sneak peek. While it's still pretty early, we can already see a couple of new features planned for Swift 6.2. The one that looks most compelling to me so far is strict checking of memory safety. By default, the mechanisms of Swift make memory management safe and efficient. But they don't prevent you from doing something risky, such as trying to manually allocate memory regions. In Swift 6.2, you'll get compiler warnings when you do so. This feature is opt-in, and even with it enabled, you can dismiss the warnings with the unsafe keyword. This change reminded me of a similar feature in Rust, which also draws a line between safe and unsafe APIs. The difference is that Rust won't compile the code at all if you don't use the unsafe keyword. But I assume that a future version of Swift will ship something like extra strict checking. As for Swift 6.2, it will likely arrive in September, and we may see a few more features revealed at WWDC in June. Personally, I don't think getting big changes at the last moment is a good approach. But frankly, it wouldn't be the first time that language stability is jeopardized for the sake of secrecy. And that brings us to the end of this video. If you found it helpful, don't forget to give it a thumbs up. Subscribe to the channel for more engineering content. You'll also find the support links in the description, in case you want to find my work on the future episodes. Until then, make your imports fly.